Today's lesson will be about solving quadratic and polynomial equations using something called the zero product property. So we will start by learning what is the zero product property and how can it help us solve equations. So let's take a look at the equation x times y equals 0. To find solutions to this equation, I'm looking for an x and a y value that will make it true. So let's try the point 5, 0. In other words, x of 5 and y of 0. Then 5 times 0 equals 0. Well, that's a true statement, which means that 5, 0 is a solution to this equation. Let's try a couple more points. What about 8, 0 or 0, negative 37? Well, 8 times 0 equals 0, and 0 times negative 37 equals 0. So these are also solutions to this equation. And what you'll notice is that the solutions to this equation, one of the factors is equal to 0 in each of these equations. What if I'm taking a look at two numbers that multiply to 24? So I've listed out some options. 3 times 8 is 24, so 3, 8 is the solution. Negative 6 times negative 4 is 24, so this is a solution. Negative 1 and negative 24, 1/4 and 96. All of these factors multiply to 24. And what you'll notice is that none of these have 0 as a factor. If we tried to multiply 0 times something to get 24, that's impossible. Nothing that we put in here will give us 24 because 0 has a special property called the zero product property, and that's what we're going to use to solve equations today. So the zero product property says the following. It says if two numbers multiply together to equal 0, then one of the numbers, at least, must equal 0. So if two factors multiply to 0, at least one of those factors equals 0. So how are we going to use this property to solve equations? Well, the goal will be that we always need to get each equation into the form something times something equals 0. And once we have the equation in this form, we can say, well, either this factor equals 0 or this factor equals 0, and we will find the x's that make that true, and those x's will be our solutions. So let's do a few examples. In our first example, we have 2x plus 1 times x minus 6 equals 0. So we're already in the right form of something times something equals 0, and all we need to do is set each factor to 0 to find the solutions. So either 2x plus 1 has to equal 0, or x minus 6 has to equal 0. Solving 2x plus 1 equals 0, I subtract 1 from both sides. I get 2x equals negative 1. Divide both sides by 2. And I get x equals negative 1/2. On the other side, I have the second option of x minus 6 equals 0, and adding 6 to both sides gives me x equals 6. Finally, I would plug both of these numbers in to make sure that both of these solutions make my equation true. So plugging in, I can see that when I plug in a negative 1/2, I get 0 times negative 6.5 is 0, that's true. And if I plug in 6 for x, then I get 13 times 0 equals 0, which is also true. So I have found both solutions to my equation. Let's try a couple more. In this example, we are going to have to factor this equation first to get it into the form something times something equals 0. So the first thing I would look for would be a GCF, but there is no GCF in x squared negative x, and negative 12. So my next method that I can look for is a reverse box method. So let's set that up. So the magic numbers that I'm going to need, I'm going to need two numbers that multiply to negative 12 and add to negative 1x. And those numbers are negative 4 and 3, negative 4x, and 3x. So I'm going to put those numbers in my box, negative 4x and 3x, and I'm going to reverse box factor out an x from that top row and a negative 4 from the bottom row. X times x is x squared, x times 3 is 3x, and negative 4 times 3 is negative 12. So my factors are x plus 3 and x minus 4. So if I come back over here, I can rewrite my expression as x plus 3 times x minus 4 equals 0. And now I'm ready to set my factors equal to 0. Either x plus 3 equals 0, which would give me x equals negative 3, or x minus 4 equals 0, which would give me x equals 4. And I can also go back and plug those in and make sure that they work. So when I plug in the negative 3, I get 9 plus 3 minus 12 is 0, correct? And if I plug in a 4, I'm going to get 16 minus 4 minus 12 is 0, which is also true. Let's try one last example and then it will be time for you to practice. In our last example, we have GCF factoring possible in this problem. So I still need to get two numbers that multiply together to equal 0 so that I can use the zero product property, but this time I have a GCF that I can pull out front. And my GCF here is 3x, and when I pull out a 3x, I'm left with 3x minus 2. So setting 3x equal to 0, I get x equals 0. And if I set 3x minus 2 equal to 0, I get 3x equals 2, so x is 2/3, dividing both sides by 3. So my two solutions here are x equals 0 and x equals 2/3, and I can now plug them back in and make sure that they make my equation true. And checking both of those x values of 0 and 2/3 do make both of these equations true. So we found our solutions. So our objective today was to use the zero product property to find solutions of equations involving polynomials. We have learned that in order to use the zero product property, we need to make sure that we are in factored form, that we are multiplying two things together, and that we have a product of 0. So we need to have 0 on one side of the equation and two factors that are multiplying to 0 in order to solve using this method.